Hello, IGCSE student. This is Tanya Chew. Welcome back to my channel. In this video, I am going to discuss Cambridge IGCSE past year paper, which is the physics paper, paper 2 multiple choice extended paper. The paper that I'm going to discuss in this video is October-November 2024 with the variant of 23, third variant. So with no time wasted, let us get started. Now let us look at the first question. Which list contains only vector quantities? Now, before you answer this question, first of all, you need to have an idea of what is a vector quantity. Let me define vector quantity. Vector quantity is a quantity which contains both magnitude and direction. What is magnitude? Magnitude is just a value. 10, 20, 30, those are called magnitude. Directions, on the other hand, it means left, right, up, down, forward, backward, north, south, west, east. Those are called directions. Right, let us look at A, acceleration. Acceleration itself is a vector quantity. Distance, on the other hand, is a scalar quantity. Speed is also a vector, is also a scalar quantity. Now the question only wants the quantity with all the quantities are vectors. Which quantities contain only vectors quantity? So A cannot be your answer because it consists of scalar quantities as well. B, electric field strength, this is a vector quantity. Momentum, it is a vector quantity. And weight is a vector quantity. B sounds correct to me, but let us check on C and D. C, energy is a scalar, mass is a scalar, and temperature is a scalar. So C is definitely not your answer. D, force is a vector, time is a scalar, velocity is a vector. No, no, no. D cannot be the answer because it consists of scalar. So the answer is B. Now, question number 2. The graph shows how the velocity of an elevator varies with time. Elevator starts from the third floor of a tall building. Point P indicates the start of the elevator's journey. Right, so point P, where is our point P? Let me highlight the point P for you to see. This is point P, start from the third floor. Right, so when is the elevator on the third floor again? Let me start from the third floor, maybe going up or maybe going down and then back to the third floor again. So let us look at the graph itself. Look at the velocity. Velocity, you bear in mind, velocity is a vector quantity, so direction counts. You look at velocity from at P, and then all the way it goes up to 5. Can I consider, if you want to consider the other way, it's not a problem. I will consider velocity upwards, moving up, right? I will assume upwards as positive velocity and downwards as negative velocity. So elevator can move up, can move down. So I will say from P to Q, elevator from P to maybe this is point A, elevator is moving upwards. And then it is, okay, moving. And then at Q, it comes down, right? Q to R. P to Q, it is moving upwards. From Q to R, it seems like velocity is equal to 0. So at Q to R, this elevator is static. That means it stopped at any of the floors upwards, which is higher than the third floor. So elevator is not moving, stationary. Door is open, so maybe the passengers or the people will walk into the elevator, and then after that, R to S. Could you see that the velocity is negative, back to negative? That means moving down, and then back to the same point as P, which is as S. Right, it seems like the elevator is moving upward first, and then at Q to R, door open, and then R to S coming down back to the third floor. S to T, that is when the elevator reached the third floor again. So C is the answer. Now, number 3, an object of mass 1 kilogram is at rest on the Earth. An identical object is at rest on a planet with a gravitational field strength of twice that on Earth. Which role correctly compares the object on the planet to the object on the Earth? Since the gravitational field strength, I just write down this is Earth, this is maybe the planet. So the gravitational field strength of the Earth is 9.8. Remember that, right? Meter per second square. Gravitational field strength of this planet is twice, 2 times gravitational field strength of Earth. Now, which role correctly compares, right? So I want you to see this. W, weight is W equals to mass times gravitational field strength. So, since this is the weight, the question asks you which role correctly compares the object on the planet to the object on the Earth. So, on Earth, this object has a weight of mass times the gravitational field strength of Earth, right? On planet, it is mass would not change. Right, mass of the object would never ever change. It is still 1 kilogram, but the gravitational field strength of the planet is 2 times the gravitational field strength of Earth. So that is why the weight will be double. But its acceleration when the same horizontal resultant force is applied. So still remember the equation of the resultant force, F equal to mama. Resultant force has nothing to do with gravitational field strength because the gravitational field strength is acting vertically downwards. When it is about horizontal, right? When you give that amount of same amount of force is being applied, it will give you the equal amount of acceleration. So the answer is A. Do you get the answer correct? Now, question number 4. An engineer researched the density of different liquids being used as coolants. None of the liquids mix with water. Each liquid is poured in turn into a container of water. Density of the water is 1000 kilogram per meter cube. Which liquids rise to the surface? That means which liquid is less dense as compared to the water. Right. So if you want the liquid rise to the surface, the liquid has to be less dense. Yeah, the density of the liquid must be smaller than the density of the water. Since the density of the water is 1000, the only one that has the smaller density as compared to the water is liquid X. So that is why X only is the answer. Question number 5. Okay, if you are aware of the passive questions and you have done a lot of passive questions, you definitely know that question number 5 is a repeated passive question. But let us discuss question number 5. Diagram shows a car moving along a road. The force due to the engines is 1,500 Newton and the total drag force is 200 Newton. What is the motion of the car? Motion, it is related to acceleration, it is related to speed, how fast the car is moving, or how slow the car is moving. Now let me find the resultant force first. R means resultant. So forward, since the force is a vector quantity, I will consider forward force as positive and the backward force as negative. So 1,500 plus negative 200 Newton. So I get 1,300 Newton as my resultant force. And do you know one more thing? If we have resultant force, we always have acceleration. So this car is accelerating with a resultant force of 1,300 Newton is applying on the car. So that is why the motion of the car must be increasing speed, but in forward direction. Why forward? Because the engine force is larger than the drag force. That is why the car is moving forward. Question number 6. A pair of cutters is used to cut a rope. Where should the rope be positioned and at which labeled points should the hands be positioned to produce the greatest cutting force? Okay, the cutting force, you have to bear in mind, the cutting force is by the blades. Don't you think so? And the force that you apply to the handle, right, has to be close to the handle. So I would say that, okay, when you apply force here, okay, the moment produce, when they ask you about the distance, when they ask you about force, this is always about moment. Produced by blade has to be equal to the moment by handle. So moment produced by the blade. Do you still remember the equation of moment? Moment, this is the moment. You learn about the moment. Moment is equal to force times perpendicular distance from the pivot. So the pivot point is actually right here. So moment produced by the blade is force by the blade times the perpendicular distance from between the force of the blade and the pivot must be equal to moment produced by the force, moment produced by the handle, times the distance of the handle. Is that okay with you? So where should the rope be positioned? Oh, the rope has to be positioned right here. Okay, if you remember, okay, because the blade is used to cut the rope. So it is related to distance P and distance Q. So which distance that you are supposed to choose? Okay, don't worry about that. Don't worry about that. If I want to produce the greatest moment by the handle so that I can cut the rope, the distance, right, must be furthest away here. The distance must be as further away. Do you still remember? I give you another example. You know, whenever you have flat tire, you want to change the flat tire, you have the to turn loose the nut, right? So you are applying the force at the furthest distance so that it is easier for you to turn the nut that is being connected to the wheel of your car. So the distance has to be the largest distance here, handle. So we take the largest force, handle, times the largest distance s, so that the moment produced will be larger, right? And force by the blade and distance blade. So what about the force on the blade? So let us see, force handle times s, which is the distance, hence position must be at s, so it's either b or d, divided by distance of the between the blade and pivot. Could you see that? If I want to produce the largest cutting force, and then that means the force on the blade must be the largest one, distance must be the lowest one because it will produce the same moment. So that is why the rope must be positioned at the shortest distance, right? Between P and Q, P is closer to the pivot. So Q is closer to the pivot. So that is why it has rope position must be at Q. D is the answer. Now, question number 7. An object has mass of 20 kilogram. Its velocity changes from 6 meter per second to 10 meter per second. Which impulse has acted on the object? Now, about the impulse, there are two equations of impulse. One is force times time. The other one is the change in momentum, final momentum minus initial momentum. Since the velocities are given, so I am going to use the change in momentum to find my impulse. Let me write down the equation of impulse. Impulse is equal to mv minus mu. Mass is given, which is 20. So how do you know which is final velocity, which is the initial velocity? The velocity that is being given first, this is called initial velocity, and the final velocity is the one that is after that. So 10 minus 20 times 6. So if you work it out, you should get 80 Newton second. So A is the answer. Now, question number 8. Useful energies obtained from different energy resources. 4 examples of energy resources are listed. How many of these energy resources depend on radiation from the sun? That means originated from the sun. Remember that, originated from the sun. Water wave, yes, you need the sun. Geothermal, do you still remember geothermal energy is the energy inside the inner core of the earth? It has nothing to do with the sun. Geothermal has nothing to do with the sun. What about the wind? Yes, due to the heating effect of the sun, right? And the movement of the air particles, heating effect of the sun that is, you know the sun, when the sun radiate out the heat, right? So some part of the earth will be hotter than the other part of the earth. And due to the temperature difference, the air particles will move, right? So when the movement of the air particles give rise to wind, so it depends on the sun. Water behind hydroelectric dams, yes, because water waves depends on the sun, right? So there are altogether 3 energy resources that depends on the sun. Now, question number 9. A box of mass 2 kilograms slides down a slope. The gravitational field strength is 9.8 Newton per kilogram. What is the decrease in the gravitational potential energy stored as the box moves from P to Q? You see, this question is quite tricky, don't you think so? They ask about the decrement in the gravitational potential energy. So I write change delta. This is called delta. The triangle is called delta. GPE, that means the change in GPE. It is a decrease because the box is moving down from P to Q. So write down the equation of the GPE, mg. This is called delta H, the change in height. So you have to bear in mind, gravitational potential energy is related to the height of the object because gravitational potential energy is being defined as the energy, right, possessed by an object when the object is given a height, right, due to the position of the object measured from the ground. So that means if the object is on the ground, gravitational potential energy is equal to 0. But when the object is being lifted up, the gravitational potential energy increases. In this case, object is being brought closer to the ground. So the gravitational potential energy is decreasing, right? So oh, 2 kilogram. And G is 9.8. The difference in height. Okay, what is height? Height is the vertical position. This is called the height from P to Q. This is the height. Right, so the height is actually 5. So remember that. You cannot use 13, you cannot use 12. Right, so the answer is 98 joules. B is the answer. Now, question number 10. The diagram shows the path of a long jumper, point R, where she lands, is on the same horizontal level as point P. From where she takes off, the long jumper experiences air resistance as she runs and jumps. This is true, right? So which graph shows how the store of the kinetic energy and the store of the gravitational potential energy of a long jumper vary with time between the points P and R? In this case, you can actually use the principle of conservation of energy. So I am definitely going to use the principle of conservation of energy, which states that total initial energy is equal to the total final energy. But in this case, because air resistance is acting, so the initial energy, because the long jumper must run, so she has kinetic energy initial, and her kinetic energy has to do work against air resistance. Work done against air resistance then only equal to at P to Q, yeah, gravitational potential energy plus kinetic energy at Q. This is Q, this is from P. Why that is the kinetic energy? Because the jumper, right, the long jumper is still running at Q. And to R, all the gravitational potential energy will be transformed back to the kinetic energy. Right, this is from P to Q, and from Q to R, kinetic and gravitational potential energy from Q to R, I better write it down for you. From Q to R, it is GPE plus KE, right? Still minus the work done against the friction. Not work done against the friction, I'm so sorry. Work done against air resistance because she is moving and the air resistance is acting. So she has to do work. Work done against air is equal to the final energy, which is the kinetic energy at R. So let us look at the graph. Do you know how to see the graph of the kinetic energy and the graph of the gravitational potential energy, right? So they have already mentioned the dotted line represents the kinetic energy and the straight line represents the gravitational potential energy. Now, let us begin with the kinetic energy first. So she has kinetic energy initially, which is maximum. It is true for all A, B, C, D. You can see that start from a certain value right here. And I cannot agree with C. Why? Because, right, C, it seems like, okay, this is called initial energy. This is how you see it, initial. And this is called final energy. It seems like the final energy is reaching the same point as the initial energy. If the question mentioned, this is another tip that I want to give you. If the question mentioned that there is air resistance or frictional force or drag force is acting, On a moving object, you bear in mind the final energy must always be lesser. It cannot be as high as the initial energy. So C cannot be your answer. Right. Now, what about at point Q? Okay, we look at point Q. At point Q, as what I mentioned is that there is still kinetic energy because the long jumper is still moving. So at point Q, this is it. Okay, she needs to have kinetic energy and potential energy. Let us see. So this is gravitational potential energy. I just count the number of boxes here. I have 1, 2, 3, 4, 5, 6 boxes for gravitational potential energy. Look at A. And then I have 1, 2, 3, 4, 5, 6 boxes for kinetic energy at A. Look at A. 6 boxes for gravitational potential energy and 6 boxes for kinetic energy. This is 1, 2, 3, 4, 5, 6, 7, 8. Right. Could you see that? Okay, it seems like A, that all the kinetic energy, which is minimum, has already transformed to the gravitational potential energy, because look at the kinetic energy drop to zero. Right, drop to zero, and then the kinetic energy, the gravitational potential energy is 6 boxes. Right, it seems like all the energy has been transformed to the gravitational potential energy, whereas there is still kinetic energy at point Q. This is not possible. Kinetic energy cannot drop to zero. Let us look at B, right? So there is still kinetic energy and there is still gravitational potential energy. It seems to be correct. And then look at D, there is still kinetic energy and there is still gravitational potential energy. Seems to be correct to me as well, right? Now, check at R. R, final kinetic energy. Final kinetic energy must be lesser than the initial kinetic energy. Let us look at B and D. We just compare B and D, which is true. This is called final, which is lesser. You look at the graph. This is also lesser, which is true. Now, the difference is that we look at point Q. Right, so for point Q, I will calculate the number of boxes. You look at, this is the gravitational potential energy. I have 1, 2, 3, 4, 5, 5 point, maybe 1 or 2, right? 5 point something. And then the kinetic energy is 1, 2. 2 kinetic energy, 2 KE. Okay, I just put 2 boxes of KE so that you could understand. Okay, at Q, right? At Q, so you have 2 boxes KE and maybe 5.2 boxes of GPE. So right, and then what about D? I have gravitational potential energy at Q. Yeah, this is at Q. The middle part is at position Q. So I have 1, 2, 3, 4, 5, 6. Okay, 6 boxes of GPE plus 1, 2, 2 boxes of KE. Right. Since the work need to be done, right, you have to understand. Okay, look at the equation that I gave you here. Kinetic energy initial must minus the work done against air resistance. So the final energy, which is at Q, in this case, P to Q, right? So the final energy, the addition between the gravitational potential energy and the kinetic energy must be lesser than the initial kinetic energy. So the sum of these two energy must be lesser than the initial kinetic energy. Look at D. So I would calculate 1, 2, 3, 4, 5, 6, 7, close to 8, maybe 7.8, for example. Right? For example, just as a guide. So you could see that at Q, this is 6 boxes of gravitational potential energy plus 2 boxes of kinetic energy. You get 8, which is higher than the initial energy, which is not logical because energy cannot be created, remember? So let us look at this one. I have 1, 2, 3, 4, 5, 6, 7. This is about 7.8. Look at the final energy, 2 plus 5.2. So it is about 7.2, right, of the total final energy, which is also true because this is called initial energy, which has to be larger than the final energy. This is called final energy at Q. At this point here, is this Q, this is all called R, this is called P. So the most logical answer is actually B. Right? So if you face any difficulties and you do not understand this particular question, please do comment below. Now, question number 11, 4 tanks contain water to the depths shown at the bottom of which tank is the pressure due to the water greatest. So pressure due to the water, remember we use this equation P equal to rho GH, where rho represents density, G represents gravitational field strength. Gravitational, I write this down for you, field strength, and H represents the depth of the water. Actually, the size, the shape of the container doesn't matter. Right? So use this equation. Let me highlight this equation for you. If you want the pressure to be the greatest, in this case, because G is constant, density is constant, right? Why? Because we are using the same water, so the density of the water must be constant. P is directly proportional to the depth. So higher the depth, larger the depth, larger the P. Which one give you the largest depth? A is the answer. Number 12, a gas is heated in the sealed container. The volume of the container does not change. What happens to the particles of the gas? You see, it is being heated. Being heated meaning to say that the temperature of the gas increases. When the temperature increases, the average kinetic energy of the particles increases. That is how you see it. Temperature is related to average kinetic energy. Right? Number 13, air in a sealed string is slowly compressed. By moving the piston, the temperature of the air stays constant. Remember, when the temperature of the air stays constant, the kinetic energy will be constant as well. You have to bear that in mind. Which statement about the air is correct? I would say that the pressure, because the string is being compressed, so the volume, the space occupied by the air is getting lesser. So the air particles will come closer to each other. So you just imagine this. If I put you in a big, large, and comfortable room, you yourself, how do you feel? You feel so comfortable. You have all the room by yourself. But if I put you into a smaller room, like a storeroom, with 10 persons together with you, all those people are strangers to you. How do you feel? Oh, I don't come close to me, but you have no choice because the room is very small. You feel pressurized. Oh, I don't like it. Because I need to have my own space, right? Same goes to air particles. I help the air particles to tell you that they don't like to come close to each other. They want to have their own space. How about that, right? So the pressure will increase because they don't have that much of the space. Pressure of the air increases because the particle now hits the string more frequently. Yes, particle cannot travel more quickly because kinetic energy is constant. Why the kinetic energy is constant? Because the temperature stays constant. See that? C is the answer. Number 14, which statement about the evaporation of a liquid is correct? So evaporation talks about evaporation give rise to the cooling effect. Remember that? Why cooling effect? Because the most energetic particles has already escaped, leaving behind the less energetic particle. Less energetic particle means less kinetic energy. Less kinetic energy means temperature is lesser, right? So the most energetic particles escape from the surface and the temperature of the liquid decreases. C is the answer. Now, question number 15, a solid is heated, causing it to expand, getting bigger. So which effect does this have on its mass and on its density? When a solid is expanding, the number of molecules in the solid or number of particles in the solid stays the same. That is why the mass will stay constant. But expands means volume increases. Yeah, back to the definition of density. Density is defined as mass per volume. Since the volume increases, the density would have to decrease. C is the answer. Now, question number 16. A glass test tube containing water is heated at the top. The water at the top boils, but the water at the bottom remains cool. This is very cool experiment. You should do it in school. You just stir it a little bit, and you could place some ice cube on top of it, and you boil it. You place the Bunsen burner close to the surface of the water. You can see magic occur. So even though bubble has already form at the top face of the water, you could see that below the test tube, right, the ice, you could place with ice, no worries, right? Place with ice, you could see that ice cubes are not melted. So which row explains why the water at the bottom of the test tube remains cool? It is because glass itself is not a good conductor of heat, poor thermal conductor, and the water itself is also the poor conductor of heat. That is why it would not, yeah, move the heat. Heat cannot travel from the top of the water to the bottom of the tube. Now, question number 17. A vertical stick is dipped up and down in water at P. In 2 seconds, 3 wave crests spread out on the surface of the water. Which statement is correct? Now, let us look at A. I will do this one by one. Distance x is the amplitude of the wave. Do you see what they say? 3 wave crests. 3 wave crest, crest to crest, right? So that is not amplitude. Distance x is actually called wave length. Distance between one crest to the other crest is called wavelength. Distance y is the wavelength of the wave. Distance y is actually double the wavelength, 2 lambda. See, each circle represents a wavefront, which is true because each circle represents a wave crest of all the wave. That is called a wavefront of the wave. D, the frequency of the wave. How do I know? I don't know the frequency of the wave. That is why I said that this statement is wrong, because they didn't give me the, oh yeah, they give me in 2 seconds. 2 seconds, I form 3 wave crests. That means in 2 seconds, okay, 1, 2, 3, right? Y is 2 lambda, right? 1, 2, 3. Yeah, 3 wave crests. This is actually 3 lambda. So 3 lambda, okay, the period, right, that is formed is actually 3 periods. So it is 3 period is equal to 2 seconds. 1 period is 2 divided by 3 seconds. So it is definitely not 3 hertz. So D is not the answer. C is the answer. Now, question number 18. Seismic waves from the epicenter of an earthquake take 100 seconds to reach a point 300 kilometers away. When they arrive, they cause the ground to vibrate with a frequency of 2 hertz. What is the wavelength of these seismic waves? So when they ask about the wavelength, I will write down the wave equation, V equal to F lambda, because the frequency is being given. Now, my main problem is I don't have the wave speed. But don't worry, they give you the time, they give you the distance. Remember, speed is equal to distance over time. So I'm going to use 300, but I'm not going to change the kilometer to meter, because you know why? Look at all the choices here. All the choices are in kilometer. So I'm not going to change that kilometer. Time is 100 seconds. So I get 3 kilometer per second as my wave speed. So 3 kilometer per second is equal to frequency 2 times lambda. Lambda is equal to 3 over 2, which is equal to 1.5 kilometer. B is the answer. Question number 19. Which diagram illustrates diffraction of water waves? Now, what is diffraction? Diffraction means spreading of wave when a wave passing through an aperture or obstacle, doesn't matter, right? A is actually the answer. B is called refraction. What is refraction? Refraction means bending of wave. Could you see that? It is slanting a bit. That means the wave has already bended. Bending of wave when wave pass through passes through two different media. Now, C is called reflection. How do I know this is reflection? Because I look at the wavelength. This is called wavelength. And it's just that direction changes and the wavelength is still there. Right? This is called reflection. D is called refraction. Could you see right here? This is refraction of the lens, right? Refraction because the lens is made of glass. So definitely the speed of the wave would have to change. That is why the wave bent. So the answer is A. Number 20, a single ray of light is reflected by two mirrors. The diagram shows a ray of light incident on mirror 1. What is the angle of reflection in mirror 2? Oh, this is so hard, right? But don't worry, we are going to do it. Now, I use my ruler. Do you still remember the law of reflection saying that this is a ray of light? This is called incident angle. Incident angle is the angle between the normal. This is actually normal. Let me highlight the normal for you. This is called normal. And the incident ray, this is called incident angle. So the law of reflection states that the angle of incident must be equal to the angle of reflection. So reflection angle must be the same. So I have to draw this. Okay, so keep my ruler just first. So this is reflection angle, 50 degrees. Now, could you see that? I want you to take special attention to this triangle right here. This is definitely not the right angle triangle. Here, this triangle right here, the one that I highlighted. Now, I want you to see another thing right here is that this is 50 degree, this is 90 degrees. Normal is an imaginary line which is perpendicular to the surface of the surface. In this case, it's the surface of the mirror 1. So this is 50. So you get this angle. How do you get this angle? It is 90 minus 50. This angle is actually 40 degrees. So 40 degrees is here. And then could you see that outside here? Okay, I draw a larger one for you. Stated that this is 60. So the angle beside 60, because one complete angle is 180. To get this angle inside that triangle, I have to take 180 minus 60. So 180 minus 60, this is 120. I could redraw back the triangle so that you can see it clearer. It is like this. So this is actually 40 degrees. This is actually 120 degrees. So the full triangle, right? So you take 180 minus 120 plus 40. And right here, you get 20 degrees. So in this case, this is actually 20 degrees. Right. And then to find the angle of reflection, I draw another normal line. Normal line is the line which is perpendicular to the surface of mirror 2, 90 degrees. Make sure that it is 90, just nice 90. Roughly about 90 right here. So I'm going to use different color to draw it so that you can see it. This is normal. So keep my ruler just first. Could you see that if this is called the angle of incident of mirror 2. If this is 20, here the angle of incident towards the mirror 2, it has to be 90 degrees minus 20 degrees, which is 70 degrees. The answer is C, 70. Why do I not finding the angle of reflection? Because I remember the law of reflection. Incident angle must be equal to the reflected angle. So since the incident angle is 70 degrees, the reflected angle must be 70 degrees as well. So C is the answer. Question number 21, which diagram shows the effect of a converging lens? Converging lens, converge, right? Converge all the light, right, together. Which one show you the converging lens? The answer is actually B. Number 22, which three regions of the electromagnetic spectrum are used in the applications listed? Sterilizing water, optical fibers, satellite television signals, mobile phones, right? Sterilizing water, actually you can use UV. And optical fiber, we use infrared. Satellite television signal, we use microwaves. Mobile phones, we can use radio waves. Right, let us see. I don't use visible, okay? All the visible I have to cancel. We don't have visible light. So the answer is B. The best answer is B. Number 23, a man stands. Okay, I have to draw this for you to see clearer. A man stands 110 meters from a high wall. He makes a short, sharp sound and then hears an echo from the wall. The speed of the sound in air is 330 meters per second. How long after making the sound does the man hear the echo? That is the echo, right? So you hear and then you get back. Okay, echo is the reflection of your own sound wave that you made. So this is a tall wall, and let me draw the man. This is the man here, and then shouting. Okay, okay, towards the wall, right? So the man and the wall, it is 110 meter. Speed of the sound. Okay, when you see, let me give you another tips. How about that? I love to give tips. When you see this word echo, right? Just see this word echo. You have to modify your equation of the speed. Speed is equal to distance over time. That is the one that I know, right? Don't worry. But when you see echo, echo means reflection of the sound wave. The sound wave must travel to the wall first before being reflected back to your ear in order for you to listen. That is why for echo, you just put 2D because the sound must travel to and fro, right? So how long? Okay, make time as a subject. T is equal to 2D over V. So 2 times the distance, 110 divided by 330, you are supposed to get 0.67 seconds. So B is the answer. Now, question 24, the diagram shows the magnetic field of a bar magnet. Wow, that's so nice. How does the strength of the magnetic field vary with position along the dotted path PRQ? Let me see, where is PRQ? Oh, this is P, this is R, and this is Q, okay? Just focus on the ones that are highlighted. So it is constant, it is not constant because P and Q are at the magnetic poles. Magnetic poles has the strongest magnetic field or magnetic force. Why? Look at the field lines, they are close together. Whereas for R, the field lines are quite further distance from each other. So let us look at the answer. It is constant. That is not true. It varies. B, it is strong at P, which is true. It reduces its strength. No, along PRQ because it reduces its strength to R and increases its strength again to Q. So this is not true. It is weak at P. No, it is strong at P. Right, it is strong at P, yes, this is true, decreases to minimum at R, which is also true, and then increases towards Q, yes, D is the answer. Question number 25, the diagram shows a charged sphere in the direction of the electric field at point X due to the sphere. An electron is placed at point Y. Which diagram shows the direction of the force acting on the electron due to the charged sphere? You see, this is the arrow. This shows the electric field, right? Acting on the charged sphere, which is inverse. So this charged sphere is actually negatively charged. Why? Because the electric field flow into negative charge. And the electron is also negatively charged. So could you see charged sphere and electron are both light charges. Light charges, they will repel each other. So what happens to the direction of force on the electron? It will push the electron away. Go away, electron. So D is the answer. Now, question number 26. A battery moves 3 coulombs of charge around a complete circuit. The battery transfers 12 joules of energy during this process. What is the electromotive force of the cell? When the energy is being given, okay, or they ask about electromotive force, I use V is equal to energy. Electromotive force is being defined as an energy supply per unit charge in driving the charge around a complete circuit. So remember? Right, this is the equation of the electromotive force, right? So electromotive force, I write it as EMF instead of V because you might confuse with PD. EMF. Right. EMF is equal to energy is given 12 and the charge is given, which is 3 coulombs. So that is why EMF is 4 volt. B is the answer. Now, question number 27. A cylinder of conducting party has a length L, diameter D, and resistance R. The party is now molded into cylinder of diameter 2D, and that has the same volume. Oh, wow, same volume. I have to highlight this. It is very, very important. By which factor does the resistance of the party cylinder decrease? For question number 27, right, you have to form an equation first. You know that resistance is directly proportional to length. You know that resistance is inversely proportional to cross-sectional area. But in this case, there is no cross-sectional area given. But hey, don't worry, cross-sectional area of the cylinder is a circle. So area of the circle is pi r squared. But you know that you are very well aware that there are no apparatus in the whole lab that we can use to measure the radius of the cylinder. Right, we have no choice. We can only use micrometer to measure the diameter. So there is a connection between R and diameter, D over 2. Sub into the equation, you have pi D over 2, the whole thing you square it. So you have A equal to pi D square over 4. Right, so I combine all these equations together. I have resistance is directly proportional to length, but inversely proportional to pi D square over 4. There is a reason why they give you the same volume, because the question did not mention that the resistance, right, when the diameter increases, what happens to the length? So I need to get rid of those length because I don't know whether the length is changing or length of the second cylinder remains constant. Right, so I put a constant, I put it as K because I want to get rid of this proportionality symbol. Length pi d square over 4. I know that volume is equal to cross-sectional area times length. Cross-sectional area I would like to replace with pi d square over 4 times the length. So length, make it as the subject, is equal to 4v over pi d square. So I can form my equation, general equation, which is K 4v, oh sorry, this is length, okay? Make length as the subject. You should be able to get this. K4V over pi d square times pi d square over 4. It looks very complicated. Yes, it is. So I try to simplify this. K4V over, V means volume, yeah, not the PD or EMF. Pi square d to the power of 4 over 4. So bear in mind, I am going to use the same equation that I derive here for the new cylinder, right? So I'm going to do it right here. Okay, maybe here we have a space right here. Okay, here. Okay, I'm doing it right here, right? So I'm going to copy down that. R is equal to K 4V over pi square. Okay, number 27. R equal to K 4V over pi square d square over 4. Pi square d square over 4. This is my first equation. Now, the new resistance, which I am supposed to find, they said that the volume is the same. It's just that the diameter has increases to 2d. So I'm going to modify that. Okay, everything is the same. It is just that this is pi, this is 2d. You have to square it over 4. Everything else is the same. Now you simplify, you get k 4v over pi 4. This is 2d square. So 2d square, wait, let me see, is it d square? Pi, oh, d to the power of 4, I'm so sorry, d to the power of 4, okay, not d square. So that is why this is d to the power of 4, right? Beware when you solve this type of question. Even me, myself, also, I make careless mistake. So I have to make sure that, okay, this is correct. Pi, okay, to the power of 4. Could you see that? Pi square. So this is pi square. 2d to the power of 4, you get 16d to the power of 4 over 4. Second equation. Now, I want to use the second equation, divide the first equation to solve these two simultaneous equations. The new r over r is equal to k 4V over pi square 16d to the power of 4 over 4, and I straight away invert that. Pi square d to the power of 4 over 4 divided by k 4v. You know what? This is my favorite part. When I try to simplify everything, k and k cancel, 4v and 4v cancel, pi d square over 4, pi d square over 4 cancel. So you have new r over the r value is equal to 1 over 16. So the new r is equal to 1 over 16 times r. So let us look at the question again. By which factor, right? Resistance decreased by the factor of 16. So the answer is D. Question number 28. Which statement describes how a diode operates in an electrical circuit? A, when the temperature increases, its resistance increases. Diode, this has nothing to do with temperature. B, when the current becomes too high, it melts and cuts off the current. This is a function of the fuse. C, it only allows the current in one direction. Sounds correct. Yes. D, it uses a low current circuit to switch on a circuit carrying a much larger current. That is only true for relay. That is why the answer is C. Question number 29. A number of identical resistors of resistance 10 ohm are arranged in circuits. In which arrangement of resistor will give an overall resistance of 25 ohm? These are all 10 ohm, 10 ohm, 10 ohm. Right. So I'll solve for A first. Could you see that A, these two resistors are arranged in parallel? So I need to find their total resistance. 1 over R total is equal to 1 over 10 plus 1 over 10. So 1 over R total is equal to 2 over 10. R total is equal to 10 over 2, which is 5 ohm. And then, okay, I just add up because these two 10 ohm, I have already simplified it, becomes 10 ohm. And this is 5 ohm, right? So the total resistance for A is 15 ohm, but I want 25 ohm. So this is not true. A is not your answer. And for B, this is 10 ohm and this is 10 ohm. I have solved for parallel circuit. So the total resistance for these two parallel circuit is 5 ohm. I want 25 ohm. So B is not the answer. For C, the three resistors are connected in series. So you have to add them up. The total resistance will be 10 ohm plus 10 ohm plus 10 ohm. That gives you 30 ohm. For D, this is 10 ohm. Okay, these two are parallel. So I have already solved. This is 5 ohm and this is 10 ohm. So when you simplify it, the circuit will look like this. This is 10 ohm, this is 5 ohm, and this is 10 ohm. So 10 plus 5 plus R total, the total resistance, plus 5 ohm plus 10 ohm. That gives you 25 ohm. That is why D is your answer. Number 30, the circuit diagram shows a thermistor and a potential divider. Two voltmeters X and Y are connected in the circuit. When the temperature of the thermistor increases, the resistance would have to decrease as well. As the thermistor becomes warmer, what happens to the reading on each voltmeter? I want to solve it for thermistor first. This is thermistor. So I use for potential divider circuit because the current passing through the resistor and the thermistor is the same current. That is why I use Ohm's law and I only compare potential difference and the resistance. Right, so Ohm's law, V is equal to IR. I is constant because it is the same current that flows through both thermistor and resistor. So V is directly proportional to R. So in this case, they mention resistance of the thermistor decreases. Resistance of thermistor decreases. That is why voltmeter Y decreases. So reading on voltmeter Y will have to decrease. But what about X? This is called the total EMF or the total voltage that is being supplied to the circuit. So the total voltage is equal to the voltage or the PD across X plus PD across Y. Since the total voltage is constant. So the PD, this is constant. Since the PD across Y decreases, PD across X must increase to balance back the total voltage. That is why Vx right? Reading on voltmeter X must increase. C is the answer. 31. In an experiment, strong magnetic fields provide a force that keeps charged particles moving with a horizontal circular motion. Positive particles are accelerated clockwise when viewed from above, as shown. Positive charge. In which direction is the magnetic field? Now, when you see this word, right, I want you to see this word, circular motion. And there is a strong force, right? They mentioned the force. When you see the force that keeps the object moving in a circular motion, you have to bear in mind the force is called centripetal force. This is the direction of the force. Since this is a positive charged particle, so it will follow the direction, okay, in this case, the direction is here. This is the direction of the current. We can actually use Fleming's left-hand rule. So the force must be towards the center of the circle. The current is flowing in the direction that I show you, force towards the direction of the circle. Could you see that my first finger is pointing at me vertically out the page? That is the answer. B is the answer. If you still don't understand how I solve this question, do not hesitate. Please comment below. Yeah. Number 32. When there is a current in a solenoid, a magnetic field is formed around it. How does the magnetic field change if the current is increased? The magnetic field, okay, when this is about the solenoid that has a magnetic field flows through it, this solenoid is called electromagnetic. Electromagnetic depends on the amount of the current that flowing through it. Larger current, larger the strength. The strength will be, when the current is increased, the strength will be stronger. So when the strength is stronger, the spacing, the magnetic fields will come closer to each other to indicate that the strength is stronger. So A is the answer. Number 33, the diagram shows the structure of a simple transformer. Bumblebee, maybe? Well, so which row shows the correct conditions for the efficiency of the transformer to be as high as possible? Primary and the secondary coil. This is about coils. Remember, we use copper wire, but we use a thick copper wire. Why we use copper wire first? Let me explain. We use copper wire because copper itself is a very good conductor of electricity, right? It has a low resistance. And we use a thick copper wire because we want the resistance to be even lesser, less heat to be emitted from the transformer to increase the efficiency of the transformer. And the core must be made of soft iron core. So that is why A is the answer. Now, number 34, the products of the decays of the nucleus of a radioactive isotope are a nucleus and radiation which is emitted. What is the nature of the product? Let us look at the first one. A nucleus of an element different from the isotope. Yes, decay will cause it to be different from the isotope and its form. And both alpha, yes, because of the alpha, it will change the proton number. That is why it is different from isotope. Isotope means the isotope. Radioactive isotopes means the two products, okay, or the two nuclides have the same proton number. But if alpha particles, which is helium nucleus, is being emitted, it will change the proton number of the product. So since the proton number is changed, so the proton number will not be the same. That is why they cannot be called isotope. Gamma, okay, when radiation, this is about gamma radiation. This sounds correct. Yes, A is the answer. But let us look at B. A nucleus of element different from the isotope is formed and just gamma radiation is emitted. Gamma has no charge, so it would not affect the proton number of the radioactive nucleus. So it cannot be formed a different isotope. Now, see, a nucleus of the same element as the isotope is formed, and both beta and gamma radiation are emitted. If beta particles means fast-moving electrons, it would change the proton number, so it would not be the same element of the isotope. When the alpha particle is emitted, it will change the proton number, so the element of the isotope would not be the same. So A is the answer. Number 34, an atomic nucleus decays by one or more radioactive decay processes. What causes the proton number to decrease by one? Proton number to decrease by one, it is about alpha or beta. So if alpha is being decayed, could you see that the proton number right, is decreased by 2. If you want the proton number to decrease by 1, you have to add to decay by another beta particles, because negative negative become positive. So it is negative 2 plus, okay, negative 2, okay, this one. Negative 2, negative and negative. I look at the proton number, just compare the proton number. Negative 2, negative, negative become positive 1. So it decreased by 1. So that is why A is the answer. Number 36, which definition of half-life is not true? The time taken for the count rate from a radioactive sample to fall to half of its original value, this is true. This is actually the definition of half-life. B, the time takes for half the unstable nuclei in the radioactive sample to decay. Yes, that is true. C, the time it takes for the mass of the radioactive material in the sample to half. This is true. D, the time it takes for the half of the neutron. Not neutron. It is related to the nucleus. So this is not true. Number 37, the diagram shows a system to control the thickness of paper produced by a machine. The graph shows how the count rate at the detector varies with the thickness of the paper. The roller squeezes the paper when the count rate at the detector drops below 12 counts and per second, and then stops squeezing when the count rate rises above 13 per second. Counts per second. What is the thickness of the paper coming out of the machine? So let me look at 12 first. 11, this is 12, this is 13. So 13 is 0.5, 12 is 0.6, right? So the thickness of the paper must be between 0.5 and 0.6. B is the answer. Number 38, the table gives the orbital durations of planets in the solar system. What is the orbital duration of Mars? Where is our Mars? Mercury, Venus, Earth, and after Earth, this is Mars. Okay, the orbital durations must be between Earth, must be larger than Earth, cannot be 295 days, and must be lesser than Jupiter. So B is the correct answer, 690 days. Number 39, which reaction produces the energy that powers in the sun? Remember the formation of the star? It is fusion of hydrogen. C is the answer. Number 40, the diameter of the Milky Way is approximately 100,000 light years. What is the distance in meters? I need to find 1 light year first. 1 light year is the distance traveled by the light in 1 year. So speed of light is 3 times 10 to the power 8. Distance is speed times time. And the time in 1 year, 365 days, 1 day, 24 hours, 1 hour, 60 minutes, 1 minute, 60 seconds. So I get 9.461 times 10 to the power of 15 meter. Then, okay, I want to change this 100,000 light year. I just times with 9.461 times 10 to the power of 15 meter. I could change it to meter, which is equal to 9.46 times 10 to the power of 20 meter. The answer is D. Yeah, that is all for our discussion today, right? In this video, I hope you find benefits, and if you have any hesitation or any papers that you want me to discuss, please do not hesitate. Just comment below. Thank you very much for watching, and I'll see you in my next video. Bye.